Okay, section 5.6. Section 5.6 is going to kind of tie together what we've been discussing with long division, synthetic division, and then this idea of the remainder theorem and the factor theorem. So before we do a little bit of review with example 1, I want you to think about what remainders are. And so I just want to pose this problem just up in the margin with you. If you were asked to show, to show that, say, 3 is a factor of 117, and then, let's say it said, then you're asked to find all the remaining factors to 117, okay? So we're going to remove polynomials from the equation for right now and just look at straight numbers. So first and foremost, if you were asked to show that 3 is indeed a factor of 117, one thing that you could do is you could simply take the number 117 and show that 3 would divide, that 3 would divide into it evenly with no remainder. Okay, that's what it really means when a number is a factor of another number, is it goes into that number evenly with no remainder. So if I could show that 117 divided by 3 gives you an answer with no remainder, that's proving or showing that 3 is a factor of 117. So if I were to do that here, I'm just going to do this with long division. This is pretty easy here, okay? We can see we get a remainder of 0. 3 goes into 117 39 times evenly. Okay, so that kind of checks off I just showed that 3 is a factor of 117. Then the second part to this was asking us to find all the remaining factors. So in other words, we know that one factor of 17 is 3, but what are all the other numbers that multiply together along with the 3 to create the 117? Well, one way of doing this is to take your answer from dividing 117 by 3 and to go ahead and factor that answer down further. Okay, like, can we break 39 down into 2 other prime numbers? And the answer is yes, we could break 39 down into 3 times 13, and then I think that's all the farther that'll go. And so the other remaining factors, in addition to the original 3 that they gave us, is another 3 and a 13, okay? So these would be all the factors to the number 117, okay? If you were to break it down into prime numbers, okay? All right, we're going to visit that idea, but we're going to apply it to polynomials here in a moment. What I would like to do is just look at example 1. They are asking you to take this trinomial, this polynomial there, and they want us to divide it by x minus 3. And we're going to try this in 3 different ways. We're going to do long division, we're going to do synthetic division, which we should get the same answer from both of those, and then we're going to just calculate direct substitution f of 3, okay? So let's go ahead and try long division. This is definitely the most tedious here. Okay, we're going to put our trinomial under our division bar. We're going to put our binomial out in front. If you recall, we're then going to compare our first terms, and we're going to say, what do we need to multiply x by to get it to look exactly like this term, a negative 3x squared? And the answer is a negative 3x. Okay, remember we then distribute and multiply that negative 3x times the x. That would give us negative 3x squared, and then negative 3x times a negative 3, that would give us 9. Okay, with long division, this is when we go through and we flip the signs, so that's going to become positive, this will become negative, we're going to add down, this cancels, we get negative 4x, we drop down the next term, and we're ready to go through this cycle one more time. Okay, again, we're looking to compare this x out in front with this negative 4x, asking ourselves, what would we multiply x by to get it to look like a negative 4x? And the answer is negative 4. We'll then distribute that negative 4 to both of the terms out in front. We would get negative 4x plus 12. Again, we need to make sure that we are flipping the signs. This cancels. We are left with a negative 8 as our remainder. So we're going to go ahead and I'm just going to make that minus, I put 8 over what we were dividing by, the x minus 3. Okay, that's our answer for long division. We could have done this problem, though, by synthetic division because it meets the criteria that we are dividing by a binomial that is both first degree and has a lead coefficient of 1. So when we do that, we grab the constant that is with the binomial, we flip the sign, okay? Then we're going to write down our coefficients. Doesn't look like we need any placeholders. We drop down our first number. We multiply -3 by 3. We put that answer in the next column. No flipping of signs on synthetic division. We add down. We multiply -4 times 3. We get -12. We add down, okay, and this is looking like this is matching with what our answer was over here. We're getting a remainder of -8. Remember, your answer is always 1 degree less than the original problem. So since this started out as a quadratic, a second degree, then our answer should be first degree. This should be -3x to the first minus 4, and then minus 8 over x minus 3. And as you compare these two answers, you'll notice that they are identical whether we used long division or synthetic division. Okay, so now this is asking us to just do this direct substitution, find f of 3. Okay, so what they're wanting us to do is substitute a 3 in for all of the x's. When we do that, we get -8 back out. And so my question to you is, what do you think that when we plugged 3 in for all the x's, what do you think that -8 is representing? Okay, if you look back at when we did the problem, either long division or synthetic division, if you look at what we got -8 as, that was our remainder. So f of 3 is the same thing as the remainder. Now, what is the importance in plugging the 3 in? Well, that is coming from the fact that we would have taken the opposite, kind of like what we do with synthetic division here. We flip the sign on this constant that's with the binomial, and we're plugging a +3 in, okay? All right, so what we just did there is we just did what was called the remainder theorem, okay? We were dividing a polynomial by a first degree binomial with a lead coefficient of 1, and the remainder that we got, -8, that remainder was also what we would have gotten if we did direct substitution. See, it says P of R instead of F of X, it's P of X. The R is coming from flipping the sign. This was a -R, so they would have plugged in a +R, okay? All right, now you might be thinking, why would we ever want to do that? Why would we ever want to, grab the opposite of this, plug it in, and it only gives us the remainder. It didn't give us the rest of the answer. So how is that helpful, just knowing the remainder? Okay, well, we're gonna see that here on the back of this notes page in just a moment. Okay? So I want to make sure that we're comfortable with this process. When you are doing that direct substitution, okay, and again, that should be the exact same answer you get for your remainder. Okay, this term synthetic substitution, be careful, it's not asking you to do synthetic division, although that's what we'll end up doing. Synthetic substitution simply means that you're going to use synthetic division to find the remainder only, okay? So synthetic substitution is ultimately only asking for you to report what the remainder is. And so what we're going to do for this problem is we're going to do this problem two ways. The directions are asking us to use direct substitution to get the remainder, and then they're asking us to use synthetic substitution to also get the remainder, and those two answers should be in agreement with each other. So for direct substitution, now I should caution you here that if they present the problem like this, f of 4, they have in fact already flipped the sign. Okay, so in other words, the original binomial would have been x minus 4. They switched the -4 to a +4, so they've already done that sign flipping for you. I would encourage you, if we have not talked yet about the store feature on your calculator, I would really encourage you to use the store feature. If you're not sure how to use the store feature, if you go to my website, there is a tab for doing different things on the TI-84 calculator, and one of those very short, like 2-minute video explains how to use the store feature. It's very, very valuable, okay? I mean, this would be the long way of doing it, just to type it in all like this. If we do direct substitution, I think the answer we get is 662. If we were to do synthetic substitution, that is us doing synthetic division, okay? Again, I just want to draw your attention to the fact that they did not show us the original binomial. They only gave us f of 4, but they have already flipped that sign. So I'm not flipping it again and putting a -4 in the box here for synthetic division. I'm leaving this as a +4. Okay, and then we go through our process here where we drop down, we multiply, we add together. Then we multiply, okay, combine this together. Oops, I think that I made a mistake. Oh, I did make a mistake, didn't I? I think I need to put a placeholder in here. Oh, I overlooked that there's supposed to be a placeholder. Okay, maybe you guys caught that. It goes from x to the 4th, x cubed, it skips x squared. So I need to squeeze like a 0 in there as my placeholder. Okay, and then I'm just going to keep going through this with synthetic division, but I'm really only interested in what my remainder is, okay? So if it asks you to do synthetic division, it just wants you to report only what the remainder is. And you can see that both direct substitution and synthetic substitution yield the exact same answer, okay? So why would we ever want to do direct substitution to only know the remainder, okay? And I guess we should mention that you can only do this if you're just testing with first-degree binomials where the lead coefficient is a 1, kind of that same criteria for synthetic division. Okay, here's the question. Is x minus 2 a factor of x to the 5th minus 3x squared minus 20? Now remember the question I posed at the very beginning of this video. Show that 3 is a factor of 117 and then find all the remaining factors. Okay, we showed that 3 was indeed a factor of 117 by dividing 3 in there and showing that there was a remainder of 0. Okay, so if I know that when these get divided, the remainder is 0, that tells me that x minus 2 is a factor. See, this isn't actually asking me to perform the division. It doesn't want the full answer from dividing. It just is asking, is this a factor? Okay, so I could do synthetic division, or I could use that nice little shortcut where we just kind of took the opposite of the constant in the binomial. So I'm going to do f of 2. Okay, and then I'm going to substitute a 2 in. Again, store feature would be really handy for this. And I just want to know, is this going to come out as a 0 or not? Okay, so we notice that if we type that in, we do in fact get that the answer is 0. That tells me that x minus 2 divides evenly with no remainder into x to the 5th minus 3x squared minus 20. So I can say that x minus 2 is a factor. Okay, I can draw that conclusion without even having to factor this, without even actually having to perform any of the division. Okay, let's try another one here. We're asked, is x plus 3 a factor of, and then here's a quartic polynomial. Okay, so I'm going to do the opposite, plug in -3 in for all of the x's. Okay, if I get anything other than a 0 as my answer, which I think I'm going to get 101, that means that x plus 3 does not divide into this evenly. There is a remainder of 101, so my conclusion would simply be that x plus 3 is not a factor. Okay, it's not a factor. Okay, we are not going to do example 6, okay? But we're going to go ahead and move on down to just these last couple examples here. I want to make sure that you're familiar with the term a depressed polynomial. A depressed polynomial is really just your answer from dividing two polynomials together. It's the answer you get. Now, the reason it's called depressed, if you think about maybe the word depressed, you probably think of maybe someone's mood and how they're really down, sad, not feeling very happy. If you think about just the term down, a depressed polynomial, remember when you divide two polynomials, your answer is always 1 degree down from the original. That's kind of where the term depressed polynomial comes from, okay? And so here are our two-step process, and I'm just going to have you write this off to the side here for these problems, is you're going to start and you're going to actually use synthetic division, okay, to see if it's a factor. Okay, we're looking for a remainder of 0. Okay, and then to reveal the remaining factors, you're going to factor the depressed polynomial. Or in other words, when I say depressed polynomial, I mean you're going to factor the answer from doing synthetic division. Now, if this just said show that x minus 5 is a factor of this cubic polynomial, we could simply do what we did up above here, do direct substitution, and either show that the remainder is 0 or that the remainder is not 0. But because there's a second part to the directions that say then find the remaining factors, we need to actually perform the synthetic division. Again, I'm going to draw your attention to what we did at the very beginning of this video. Showing that 3 was a factor, I actually did the division because the second part to this was then find all the remaining factors. And remember how we did that? We took the answer from dividing, like the depressed polynomial, and we factored that answer to reveal the other remaining factors. And that's what the process is going to be for this, okay? So let's go ahead and do synthetic division. I'm going to put a positive 5 off to the side. I'm going to go ahead and write down my coefficients. Doesn't look like I need any placeholders. Okay, should be able to move through this synthetic division process pretty quickly. Okay, I'm noting that, okay, we do have a remainder of 0. And the way this was worded is it did say show that it is a factor, so I was anticipating that we likely would get a remainder of 0 because of the way that it was worded in the problem. Okay, so I just showed that x minus 5 is a factor because it divided in evenly, but then it's asking us to find all the remaining factors. And so what I need to do now is I need to take my answer, that depressed polynomial, and I need to factor that further. Okay, we've talked about factoring. This would classify as a trinomial with a lead coefficient of 1. So we would be looking for two numbers that multiply to be -3 and add to be -2. That'd be -3 and +1. Okay, so when you write your answer, you're just going to write down what all of the factors are to your problem. Okay, don't forget to include the one you were given in the problem, the x minus 5, and then also next to that put the x minus 3 and the x plus 1. Okay, all right, let's try one more of these here. We're going to show that x minus 2 is a factor of this cubic polynomial. Going to do synthetic division. Okay, again, as we anticipated, got the remainder of 0, so I know x minus 2 is definitely a factor. Okay, this was third degree, so I'm going to be taking my depressed polynomial, which is a second degree. I'm going to factor that further to reveal the other remaining factors. I need two numbers that multiply to be -6, but add to be -5, that would be -6 and +1. And then I'm just going to list all of the factors for this. Okay, we want to definitely include the one you were given, x minus 2, and then x minus 6, x plus 1. Those are these two here that we got. Okay, in the last problem, I believe I did that one for you there. Okay, your assignment